Good evening, or afternoon, or morning, or whenever you choose to watch this. This is Mr. Keener here with another lesson, this time about finding the roots of polynomial functions. Let's begin. That is a picture of my cat. I felt left out with the whole cat thing. That is Cha-Cha. She's adorable. She stops me from grading tests sometimes. If you're allergic to cats, don't sniff your tests too closely. All right, here we have 4 graphs. Let's get them in the frame. 4 graphs of, we can see they're quadratic functions because of that shape that we all know and love, the quadratic parabola right there. Now, the question is asking, the graphs below represent functions defined by polynomials. So a quadratic equation is a polynomial equation, a polynomial function. For which function are the zeros of the polynomial 2 and negative 3? Now, if you recall, the zeros, also known as the roots, or in some cases the solutions of the graph, can be found by locating the x-intercepts. So let's go ahead and label the x-intercepts on each graph, and let's identify what the solutions are. So we have an x-intercept here at x equals negative 2 and positive 3. And then we have x-intercepts here at negative 3 and negative 2. Haven't found what we're looking for yet. We're looking for positive 2 and negative 3. Can't be that one. This one, both of the x-intercepts are positive, so we know it can't be that because we need a negative root here, a negative intercept. So let's take a look at this last one. We have positive 2 and negative 3. So that's all this question is asking. For which function are the zeros, 2 and negative 3? It's just asking for which of these functions does it cross the x-axis at positive 2 and negative 3. So in this case, it's just 3. So a quick recap of some definitions here. Remember that the roots, also known as the zeros, are found where the graph intersects the x-axis, also known as the x-intercepts. The zeros can also be found by setting the equation of the function equal to 0, that's why it's called zeros, and solving. And we use the quadratic formula for that. Or we can factor. So this first example, find the zeros of the function f of x equals x squared plus x minus 6. Now we know this is a function because it's in function notation, f of x. Now when we see this, we can sort of treat it like this is a y. Y equals x squared plus x minus 6. And now we can start factoring the way we always do. We're looking for 2 numbers that multiply to negative 6 and add to 1. Those are going to be negative 2 times 3. Negative 2 plus 3 is going to give us 1. So since my a value is 1, we can do our 1am method. And let's go ahead and write these as 2 binomials, x minus 2 times x plus 3. And to solve this for 0, we're going to set it equal to 0. And then we're going to go ahead and split it up into 2 separate equations. X minus 2 equals 0, and x plus 3 equals 0. Solve for each one, we'll end up with a solution set of 2 and negative 3. Now, if 2 and negative 3 sounds familiar, it's because those were the 2 solutions in our example problem. So we solved it algebraically, and we also solved it by looking at the graph here. Now, it's important to understand that when we do look at a graph, we can tell what the equation might be simply by looking at the roots. So believe it or not, this graph, all we know about it is that the roots are at negative 3 and 2, and we can actually guess to what the equation is for this line, even though we can't see it. So the equation of this line is x minus 2 times x plus 3. Don't believe me? Here's that same exact thing on Desmos. Look, it's the exact same thing, and we can see our roots at negative 3 and 2. All right, let's get into the nitty-gritty. Here is our first polynomial function question. So we notice these are not quadratic equations. We can see that it does not have that parabola shape, but nonetheless, we can still use the same strategy to either find the roots or to identify the factors of the equation by looking at the roots. All right, let's read the question. A polynomial function contains the factors x, x minus 2, and x plus 5. Which graphs below could represent the graph of this function? Okay. So what it means when it says factors of x, x minus 2, and x plus 5, it's saying that we could write this equation using these as our factors. Now, there could be more factors, but it definitely has these as factors. There could even be a GCF. We don't know. But the information it gives us is that these are the factors. Now, just like in our factored form, we can find the roots by solving for 0. So we're going to go ahead and set this equal to 0. Now if you remember our zero product property, we don't need to look at the whole thing. We can look at each individual factor. If we set each individual factor equal to 0, we can find the roots. So our first root is going to be at simply 0 when x equals 0. So which of these graphs have a root at 0? I guess probably a better question, which of these graphs does not have a root at 0? We can eliminate 2 right now. We can see that at x equals 0, it does not cross the axis, so it can't be that one. But at 1, we do have a root of 0, and we have another root of 0 here. Now, ignoring that, because we've already taken care of that particular factor, let's look at x minus 2. So x minus 2 is 0 when x is equal to 2. So that means we are looking for a graph with a root at 2. So 1 has a root at x equals 2, and 3 does not, so we are left with only 1 left. And if we look at our choices, that is an option. But just to make sure, let's go ahead and check to see if that last root makes sense. X plus 5, this is going to evaluate to 0 when x is equal to negative 5. So that means that we have another root at x equals negative 5 if we look at our first graph. Bada bing, bada boom, there it is. What about this one, our forgotten number 3? Well, we didn't choose this one for our previous one, but we can figure out possibly what some factors of this are just by looking at the graph. So we can see that we have roots at 0, at negative 2, and at positive 5. So we can actually work backwards from the roots to find the factors. So if it's got a root at 0, we know one of the factors is x. If it's got a root at negative 2, we know that x plus 2 is going to equal 0. And if it's got a root at positive 5, we know that x minus 5 has to equal 0 at some point. So these can be our 3 factors, and we can write it out like this. X times x plus 2 times x minus 5. Let's take a look at the graph on Desmos. Okay, well, it doesn't look exactly like what we expected it to, but we can still see the roots at negative 2, 0, and 5. And we can play around with the coefficients here, add perhaps 1/2 or 1/4 to the front of this to change the shape of the curves, but the roots will stay the same. All right, let's move into a new example. This time it's asking us to find the zeros of the function f of x equals x plus 1 times, and then we have a whole trinomial here in parentheses, x squared plus 4x minus 5 algebraically. Now, we're given essentially 1, 0 here, x plus 1. We know that we're going to have a 0 at x equals negative 1, because when this is negative 1, this whole thing is going to evaluate to 0. It doesn't even matter what goes on inside these parentheses, because if this is 0, the whole thing is 0. That is the zero products property. So what we can do is break down this trinomial into binomial factors. Oh, it looks like a little guy. That's fun. And we can do that by factoring. So x squared plus 4x minus 5. We're looking for 2 numbers that multiply to negative 5 and add to 4. I'll give you guys some time to figure out what should go in these parentheses. You can pause the video right now if you want to take a look. Alright, well, our factors are x plus 5 and x minus 1. We can also go ahead and add that to it. This expression right here is equivalent to the expression above. So in the expression above, we had a binomial multiplied by a trinomial. Here we have 3 binomials, but you'll see that no matter what the value for x is, you're always going to get the same value no matter which of these expressions you use, whether we use the 3 binomials or the binomial times the trinomial, which is, of course, the definition of equivalent. These are the same. They just look differently. When you get a haircut, you're the same person, you just look different. You don't change your DNA when you get a haircut. You just got a new look. You put on new clothes, you look different, but you're the same person. I think you understand the analogy. I'll move on to something else. All right, so now that we have it in a new form, it makes it easier to find the zeros. We're going to do it the same way we do it with any others. Just set each one equal to 0, and then solve x plus 1. Obviously, we already did that one. X equals negative 1. X plus 5, we're going to have a 0 at negative 5. And x minus 1, we're going to have another 0 at x equals 1. There's our 3 zeros. This function is going to cross the axis 3 times. Don't believe me? There you go. Here is what the graph looks like. We can see it crosses here at negative 5, negative 1, and positive 2. So we have our 3 roots there. All right, here is a new problem. This one I'm going to let you guys work through on your own. So pause the video, see if you can find out what the 3 zeros of this function will be. Alright, here are your answers. Since x minus 3 is already in binomial form, all we have to do is factor this trinomial here. We end up with x minus 6 times x plus 1. These are our 3 factors. We set each one equal to 0, and we get our 3 solutions. They are x equals 3, x equals 6, and x equals negative 1. That means that on the graph, it will cross the x-axis at these 3 points. Alright, here's the final question. The graph of f of x is shown below. We can see, obviously not a quadratic. This is one of those polynomial functions. Which function could represent the graph of f of x? So could being the key word here. All we know about this graph are the roots, so we need to figure out what the factors could be, and then which of these 4 equations represents those proper factors. So, where are our roots? Alright, our roots are at -4, -2, and +1. So we are expecting to find an equation that could look something like this. X plus 4, that represents our -4, times x plus 2, that represents our -2, and x minus 1, which represents our +1. Now, we can see up here that we actually don't have these choices, so it looks like we're going to have to figure out which of these trinomials, or we're going to have to factor these trinomials and then compare it. Now, we can be strategic and eliminate some. I'm going to let you guys do it on your own. Go ahead and choose the correct answer, and that'll be the end of the video. Alright, hope you guys learned. I hope you guys understand. If not, rewind. You can listen to my voice again. If you want to go back and look at the picture of Cha-Cha, I completely understand. She's adorable. That's all I got for you tonight.